All right, here we are at topic 3, block 3 on patterns and proportional relationships, page 73 in your math book. So make sure you have your book open to page 73. And we're going to start right in with question number 1 here that says, each medium cheese pizza costs $7. Well, great. So if that's the case, then we should be able to complete this table and graph for this particular pizza relationship. So if we buy 0 pizzas, well, how much would that cost? Well, that would be 0 multiplied by 7, right? Which would be 0. If you don't buy a pizza, you shouldn't have to pay for anything, correct? All right, sure. And then if you buy 1 pizza, that would be 1 times 7, which would be $7. Sure, it would. 2 pizzas multiplied by $7 each should be $14. Let's see, 3 pizzas. I don't know. Now we're getting up into the threes. Just kidding. 3 times 7, that's going to be $21. 4 pizzas at $7 each would be $28. All right. Well, there you have it. There, we filled out the table. Now it should be pretty easy to fill in the graph. Now, what I'm going to do first of all is I'm going to expand the page here a little bit to make life a little bit easier. And remember, this is our x-axis. And up here on the vertical is our y-axis. And so this is our input. The x is our input number. So the number of pizzas, here's 0 pizzas. I'm going to skip lines. That would be 1 pizza, 2, 3, 4, and so on. And then let's see, if I go up the side, I would say, I think I'll skip count by 5s, but I won't count all of them. That'll be 10. So 5, 10, 15, 20, 25, 30, 35, 40, and so on. Now, if we want to draw this, let's see here. Let me check my dot size. Perfect. So if we bought 0 pizzas, that would, of course, be 0, 0, right? 1 pizza is $7, so that would be 5. There's 5. 7 looks like it would probably be about there. 2 pizzas is 14, so over to 2 and then up to almost 15, but not quite. 3 pizzas is 21, so we'd go up to 20, and just past 20 would be 21. And 4 pizzas would be 28, so just not quite to 30. So if we've done everything right, this should, if this is a proportional relationship, we should be able to draw a line through those points fairly easily using our drawing tool. In your case, it'd be a pencil and a ruler if you've got your book. And I'll draw my line. And if I've done everything correct, these should line up rather nicely. Roughly like that. Okay. So, lovely, lovely. Now we have the graph, we have the table. Now we have to find the algebraic rule. So let's think about this. Remember, the number of pizzas, that is our input. That's our x, right? I can put this down here, x. And the cost is going to be our y. So how much will our cost be? Well, if you looked at this, the first one is 0 times 7, 1 times 7, 2 times 7, 3 times 7, 4 times 7. And then if it's x, well, then that would be x times 7. But what is x times 7? Well, that would be 7x, right? X times 7 is 7x written properly. So if we want to find an algebraic rule that represents the relationship between the number of pizzas, that's our input, and the total cost, that's our output, our algebraic rule would look something like y, the total cost, is equal to 7 multiplied by the number of pizzas. See how easy that was? Piece of cake. Easy peasy lemon squeezy. All right. So we've filled out the table, we've graphed the data, and now we have written the algebraic rule. So now we can use that rule and our information to do oh so much more. So what we've got here is we are going to use the algebraic rule that we wrote. We're going to calculate how much it would cost to buy 10 pizzas. So of course, we're going to use that algebraic rule of y equals 7x. And what is x? X is the number of pizzas. So it says we're going to buy 10 pizzas. Y equals 7 times 10. Make sure you're writing this down in your book, because if all you do is skip to the end and write the answer, you're missing out on the most important part. The answer isn't the most important part. It's how you get there. Now, 7 times 10 is, of course, 70. So y is equal to 70. So now we know our final answer is it would cost $70 to buy 10 pizzas. Now, the cool thing about this algebraic rule that we've written, this one right here that we've been talking about, y equals 7x, the great thing about that is you can use it to answer two different questions here. You can say, well, if I want to buy 10 pizzas, how much am I going to spend? But here's the other thing. This next question says, if you have exactly $84 to spend and you want to spend it all, how many pizzas can you order? We can still use the same equation, y equals 7x. Because now in this case, the $84, 84 isn't the number of pizzas. It's the amount of money that we want to spend. So we're going to substitute 84 for our y value because that's the total amount spent. 84 equals 7x. See how I substituted 84 for y? Now I can divide both sides by 7. Whoa, I don't want to do that. That's too big a line. Sorry about that. I can divide both sides by 7. And when I do that, these two 7s cancel each other out. And 84 divided by 7 is 12. And we are left with x. So 12 equals x, or x equals 12. So that means, what is x? X is the number of pizzas. So we can order 12 pizzas with $84. And if you want to check to make sure that's right, well, then you go, okay, 12 times 7 is 84. Yep, we're good. Now, that takes us to question C. Now, this is an interesting question. What if you buy 0 pizzas? How much would that cost? Well, gosh, let's write out our equation just to make sure. Y is equal to 7x. So that means y would be equal to 7 times 0 pizzas. 7 times 0 is 0. So it would cost $0 to buy 0 pizzas. Does that make sense? If you don't buy a pizza, should you have to pay any money? Of course not. So this does make sense. It makes sense because 0 pizzas should definitely equal $0. It should anyway, right? I mean, what if you didn't order pizza, but the Domino's guy shows up at your door and says, that'll be $8, please. I'm sorry, what? Well, I was driving in the neighborhood and I thought I'd stop. And since I'm making a delivery, I'm going to charge you a delivery charge, even though I don't have a pizza. What? What? It just doesn't make any sense. 0 pizzas. If you don't get a pizza, you shouldn't have to pay anything. Okay. Well, let's move on to number 3 then. We're having such a good time. Question number 3 says, cheese pizzas must be at a different place. Cheese pizzas cost $7 each. Okay, this is a different pizza place. It's got to be. And there is a one-time charge of $5 to have your pizza delivered. Oh, see, now we're talking about delivery. $5 charge to have your pizza delivered. So let's answer the following questions about this situation. So make sure you're filling in your table. So let's see. Here's our X again, right? X is the number of pizzas we are ordering. Y is the cost. And so if we buy one pizza, well, that's going to be um, 1 times 7 plus we have to pay that $5 delivery charge. So 1 times 7 is 7 plus 5 is $12 because you're paying for the delivery. 2 pizzas would be 2 times 7 for that. And then you still have to pay that delivery charge, that one-time delivery charge. 2 times 7 is 14 plus 5 is 19. All right. Now 3 pizzas is going to be 3 times 7, 21 plus $5, $26. All right. And the last one now is 4 times 7, 28. 28 plus $5 is $33. All right, so we filled in our table. Now let's fill in our graph. Remember, our x-axis is the number of pizzas, and our y-axis, that's going to be the cost. And if we set it up the same as we did last time, so let's see, this is 10, 20, 30. Oh, that's in the way. 40. Okay. And 1 pizza, 2 pizzas, 3 pizzas, 4 pizzas, and so on. Okay. Let's go with our heavy dot. All right. Where's my, there he is. Okay. So 1 pizza is $12. 1 pizza, $12. So there's 10, 11, 12, probably about there. 2 pizzas, 19. So almost to 20. 3 pizzas is 26. Let's see, there's 20, 25, 26 would be about there. 4 pizzas is 33. 25, 30, about there. Okay. Now, if we, let's say we connect these dots with a line. So I'll do that, get my graph going here. And let's see if I can connect my things with a line here. Shoot. So I want you to look at something here. What if I start here at the origin, right? And I try to connect these dots. Can I connect these dots by going through my origin? Look at that. I try to connect my dots by going through the origin, and I can't. So I can't do that. So let me get rid of that one. Don't like that one at all. So we'll try it again. Only this time, I'm going to start at my 5 here. And now can I connect all my dots through that? Can I draw a straight line through all my dots? Yes, I can. So I want you to pay real close attention to this spot right here where it crosses the y-axis. So that says that 0 pizzas, 0 pizzas. All right. Well, we've drawn the graph. We've filled in the table. We're good to go. Now let's write our algebraic rule. Remember, we've got to write the algebraic rule. Are you kidding? Without an algebraic rule, the world would fall into chaos. So if the number of pizzas is x, right? So we've got 1 times 7, 2 times 7, 3 times 7, 4 times 7. Well, this would be x times 7. 7 plus 5. Don't forget that plus 5. So what will our rule be? Oh, we've got that dollar signs in the way. I'm going to move that. There we go. What would the rule be? Well, y would be x times 7 is 7x, but then we have to add that $5 delivery charge. 7x plus 5 is our algebraic rule. So if we're going to write the algebraic rule in terms of x and y, we would say, fine, our total cost in dollars, that's our y value, is equal to 7 multiplied by the number of pizzas that we order plus a $5 delivery charge. I don't see any question marks in the chat, so I'm assuming that we're doing great. We're doing just marvelous. So let's go on to question 4, because we're going to use everything that we did in number 3 to answer question 4. So how much would it cost to buy 10 pizzas and have them delivered? Well, then we would use this. Y equals 7 times 10 pizzas plus $5. Right? And that would be 7 times 10 is 70 plus $5. That equals our total cost. And so then our total cost is going to be 70 plus 5, $75. So it will cost $75 to order 10 pizzas and have them delivered. Okay. Now this one seems a little weird, but we'll answer it anyway, and we'll treat it like it's a question we haven't even seen before. If you have exactly $75 to spend, how many pizzas can you order? Well, let's work this thing through backwards. Remember, this is our total cost. So instead of a y, we will say, well, 75 is equal to 7x plus 5. First step would be to subtract 5 from both sides, because we have already learned how to solve multi-step equations. And this 5 and this negative 5 go away. 75 minus 5 is 70, and that equals 7x. Okay, I'm just moving over because I don't have room to move down. And divide both sides by 7. And those cancel each other out. And I get 70 divided by 7 is 10. 10 equals x. And x is the number of pizzas, so we would be able to order 10 pizzas. Now, I know that we already knew that from the question before, but we needed to treat it like it was a separate question so you can see how you can work it backwards using the same equation. Now, question F is a fantastic question. What if you want to buy 0 pizzas? How much would that cost? Well, let's find out. The total cost is equal to 7 multiplied by the number of pizzas, which is 0, plus 5. Right? So the total cost is 7 times 0, which is 0, plus 5. And 0 plus 5 is 5. So the total cost would be $5 for 0 pizzas. So it would cost $5 in this particular situation to order 0 pizzas. Does that make sense? Remember I told you about the Domino's guy that just stops by your house and says, yeah, I was in the neighborhood and thought I'd deliver a pizza, but I didn't have one for you, so that'll be $5. What? It's because for this particular equation, y equals 7x plus 5, if you look at the graph, when x is 0, y is 5. Because that's where it crosses the y-axis. Because it's got that one-time delivery fee. But it doesn't make sense. Nobody's going to expect you to pay a delivery cost if you don't buy a pizza. That's just silly. But you can see where the math, in some instances, doesn't work out. And the reason for that, the reason it doesn't make sense is because this is not a proportional relationship. So in this case, if it's not a proportional relationship, it doesn't make sense. If you didn't buy something, you're not going to pay for something. But in this case, well, the math says that you do, but common sense says no. All right. So we will continue this in our next lesson. You don't have any homework tonight, so make sure you work on any missing assignments that you may have and try to get caught up.